Okay, so I want to show you make a video here and show you how to use, um, how to deal with using probability to solve probability problems using combinations. That's where I want to go next. So let me title this Probability Using Combinations. Here we go. Probability using combinations. And I've seen these type of problems on tests, I believe, and so it's very important. I want to show you two examples. They're pretty much similar to each other, but nevertheless they're important. So let's see two examples of the same thing, essentially the same thing. Let's say you've got four cats. Problem number one. You've got four cats. Okay, and besides the four cats, you've got five dogs. Okay, now, and you're going to choose five animals randomly. So you choose, let me put a period there. You choose five animals randomly. Obviously, they're going to be either cats or dogs, or it could all five of them could possibly be five dogs, or else you can also get four cats and one dog, but you can get all sorts of combinations. You choose five animals randomly from these four cats and five dogs. Okay, and now what's the probability that you're going to get? What's the probability? Here's the question, of course. What's the probability that you wind up with, or you get, two cats and three dogs? Two cats and three dogs. That is the question. Okay, so here's what it comes down to. Is order important? It's going to be a numerator and denominator. That's what I'm setting up for. Is order important? So you're going to choose randomly five animals. You don't care how these animals, let's say it turns out to be four cats and a dog. You don't care if the first one you choose is a cat, then a dog, then another three cats, or you choose four cats and then the last one you choose is a dog. It turns out that you have four cats and a dog. So order is not important. Okay, so if that's the case, what is the sample space? This is a probability question. What's the probability? So we need to figure out what the sample space is, and whatever, then that's going to be all the possible outcomes. Remember what sample space means, all possible outcomes. And where is that going to be put? That's going to be put in the denominator. All right, so here is how to figure out the denominator, the sample space. It's a combination because we don't care about the order. There's a total of 9 animals, 4 cats and 5 dogs. How many are you selecting? You are selecting 5, 2 cats and 3 dogs. So those are all the possible things that can happen. You're selecting 5 animals out of 9 animals. And the order is not important, so it's a combination. Okay, here comes a little bit more difficult, the numerator. So what are you choosing? You're choosing 2 cats, right? What's the possibility? Notice this is the desired result. What is the probability that you get 2 cats and 3 dogs? Meaning the desired result that we're looking for in the numerator is that you get 2 cats. Where are the 2 cats coming from? They're coming out from 4 cats. Out of 4 cats, you're choosing 2, and order is not important, so it's a combination. Where are you choosing the 3 dogs from? You're choosing the 3 dogs from the 5 dogs. There's 5 dogs to choose from. You're choosing 3. That's where you're getting them from the 5. And what is it? It's also a combination because order doesn't make a difference. And you guessed from previous videos that there's no plus in between here, but there's all these combinations of what you can get for the cats combined with all the combinations you get for the dogs, so they multiply each other, and there is your numerator and denominator. Now, I don't want to really go through the numbers. Maybe I'll do a little bit of the numbers here, but again, the calculator will help you get through the numbers. Let me move this thing up, and we can do a little bit of the numbers, and you can always use a calculator for the rest. What would this turn out to be? So let me do some scrap paperwork over here. Here's some scrap paperwork. Let me cordon this off and cordon this off. Scrap paper. So the 4,2 would turn into 4. Remember the formula. 4 factorial over 2 factorial, and 4 minus 2 is another 2 factorial. This would turn into, if you pick on one, it's a tie, so I might as well pick on 1. 4 times 3 over 4 times 3, and then you get to 2, stop, and this is done, over 2, so it's 12 over 2, which is 6. So the top left would turn into 6. The numbers are not too bad, so maybe we can do it together here. What about C53? It would be 5 factorial over 3 factorial, and 5 minus 3 is 2 factorial. All right, I'll just remind you about CNR. CNR, the formula is n factorial over r factorial times n minus r factorial, right? So that's where I'm getting these numbers from. Okay, what does this turn on to? Take the big one on the bottom. You get 5 times 4, get to 3, stop, over 2 factorial. That's 20 over 2 is equal to 10. So this would turn out to be 10. It's pretty easy numbers, actually. The last one, maybe a little bit bigger of a number. Let's see. 9, it'll be 9 factorial over 5 factorial. And 9 minus 5 is 4 factorial. Okay, pick on the bigger one. Move it over here. 9 times 8 times 7 times 6, you reach 5, stop. 4 factorial is 4 times 3 times 2, I don't need the 1. All right, the 3 times 2 is 6, I might as well cross that out with the 6. The 4 factorial goes into 8 twice. What do we have? We've got 18 times 7. 18 times 7. What's 18 times, 1 second. 18 times 7, let me put that over here. 18 times 7. You'll see what I mean in a second. 18 times 7. The 6 goes into 6 once and into 18 3 times. So that was advantageous. What do we have at the end of the day? 10 over 21. And that is the bottom line answer. Okay, I'm not really care about the numbers that you can do with a calculator pretty easily. And if they want if they want decimal, you do 10 divided by 21, and you get your decimal. If they want percent, you move it over, the decimal place over, and you get your percent, etc. All right, that's problem number 1. Now I want to show you problem number 2, pretty much the same type of problem, but I want to show another example anyway. Okay, here comes problem number 2. Pretty much the same problem, but this practice I think will be useful. What if you've got as follows for problem number 2? The situation is where there's 10 women and 9 men. 13 out of these people are chosen. 13 are going to be chosen from them. 13 are chosen for whatever it is, whatever the situation is. They're chosen out of there for to maybe decide a matter or whatever. It does. You can make it up. We can make it up ourselves. But here's the question: what is the probability of choosing 8 women? What's the probability of choosing 8 women? I'll put a W there. And 5 men. Right? Obviously, everything's random. What's the probability of that happening? When you're choosing 13, what's the probability that you're going to end up with 8 women and 5 men? 8 plus 5 is 13, of course. You choose 13. What's the probability you're going to end up with 8 women and 5 men? Okay, very similar to the last problem. What's the denominator? The denominator is going to come from here. not just from here, from these two, from both of these statements. 13 are chosen, 10 women, 9 men. How many are there in total? We want all the possible outcomes. So how many are there in total? 10 and 9 is 19 total, and we're choosing 13. Is order important for what they're being chosen for? No, it's another combination situation. Okay, what are we looking for? We're looking for, of those 13, it turns out to be it's 8 women. How many people are you choosing for women from? 10 women. Out of 10 women, you're choosing 8. Right in front of there, we put combination because the order is not important. We don't care. As far as the men is concerned, we're interested in a situation where you actually come up with 5 men out of how many? 9 men. 5 out of 9. It's a combination because order is not important, and there's a multiplication in between, and these numbers are big. You need a calculator for all this stuff. And so I just wanted to show how to get that job done. That's what I needed to show these two problems, considering of probability using combinations. Let's close this video. Here we go.